Hello and welcome to another episode of the Cables to Clouds podcast monthly news update. And as always, I'm Tim and I'm here with Chris, my excellent co-host, and we are just going to dive right into the news. Of course, we have the news available in our show notes. You can get a list of all past, present, but not future yet articles for your viewing
we don't have
pleasures.
That technology yet.
Yeah, we're not there yet. We will be, though, because AI is going to bring it to us somehow. All right, let's just jump into it. Our first article is about Huawei releasing a new open source technique that is supposed to shrink LLMs to make them run on less powerful and less expensive hardware, which, you know, if it works, God, it's about time somebody went the other way versus making it run on bigger, more expensive, and more energy-hungry hardware. So according to this article, Huawei's Computing Systems Lab has introduced a new open-source quantization method for LLMs aimed at reducing memory demands without sacrificing output quality. So they call this thing SINQ, S-I-N-Q, and the basic gist of it is that, you know, it's from a network engineering perspective, it reads kind of like it's like cut through switching or something. So it's basically shrinking the heavy math involved with you know, AI, LLM training and LLM expression to, you know, keep just lower the amount of memory that's required to run some of these mathematical algorithms without too bad impacting the output quality. So it mentions that it is available, you know, on GitHub and Hugging Face. It's using the Apache 2.0 license, so it's completely open source. They've tested it on a few models like DeepSeek, for example, and it just goes. The article goes into the details far more than I could as someone who is not an AI, you know, geek here on the learning perspective, but it goes into the algorithms and how it actually cuts down the math. And so this is a really interesting article. I would love to see this validated. Said God knows we could use some cheaper hardware for once on this. You read this article recently. What do you think?
Yeah, it's I think kind of to what you said, it kind of reads like, you know, the idea that we all commonly see in network engineering about doing a little bit more with just kind of the first few details of the, you know, kind of the packet rather than looking at the entire thing end to end, right? And only looking at the stuff that's relevant. So that's kind of how it reads. But to your point, there's a lot of math involved here that goes very in depth about floating point numbers and things like that. So if that's your shtick, then I highly recommend checking out the article and reading into it because it is quite interesting, but probably a little above my head on a lot of this. It does make me wonder two things, and the first thing is where does this plan to get us? Like, I understand running on cheaper hardware is easier, but like, is this kind of moving towards it, you know, running these models locally on things like handheld devices, like actual, you know, smartphones or even OT type devices, scanners, things like that? Or does this put it running on pieces of infrastructure on site inside of a rack somewhere? And the other thing is, unfortunately, we have to call this out, but this is brought to us by Huawei, which Huawei is one of the largest, you know, consumed vendors for IT infrastructure in certain parts of the world, but they also have kind of a resounding reputation about them in the rest of the world. You know, there are certain organizations that will not touch Huawei just based on that reputation alone. So right. I wonder if that will kind of impede potential adoption of this, which is, you know, this is a completely open source thing. It's free to use based on Apache 2.0 licensing. So it's ready to be used for free. But I wonder how much, you know, it'll actually take off just because of that reputation.
Yeah, that's a great point. Maybe that's why they went the way they did, actually, with the open source licensing and just kind of throwing it all out there, kind of being aware of that, or maybe just, who knows, right? But that's a very good call out.
All right. Next up, this will be a brief one, but it's just funny to even see this written down. But we have an article here from CIO Dive saying that global AI spending is intended to approach 1.5 trillion spending this year, according to Gartner. Talking about the obviously large investments from many different organizations. Actually, it doesn't seem like there's a lot of customers investing in this. It's all other vendors investing in this, et cetera, other service providers, et cetera. But just crazy that we're thinking in terms of trillions now, 1.5 trillion in spending. So, that's the numbers that we're talking about. If you think enough, if you think tons have been spent already, it sounds like it's only going to increase in a pretty exponentially larger pace. This is, and I think ChatGPT just launched I forget what it's called, where you can actually let ChatGPT do transactions for you. Like you can give it your credit card info and it can do purchases for you, like in-app purchases. So, this is the future we're headed towards.
How could that go wrong? Oh man. Now the article points out as well, like capacity constraints continue to be a problem, and simply throwing more money at investment in AI is not really solving that problem. There's plenty of money being thrown at development of new data centers and grid, but like the grid is what it is, like we've got companies now buying nuclear reactors to fuel their AI workloads. But like you can't build it but so fast, right? This whole bubble could have popped long before the first data centers that were built as a result of all this money changing hands even goes online. So I'm very curious to see where all this money is really going, because the money is getting spent very, very quickly, but all of the horizons on the result of the thing we're spending money on are like years away, which, as we've seen AI changing this quickly, it's got to stall out at some point because they're just going to run out, of runway essentially, no matter how much money they throw at it. So that's why the Huawei thing actually is somewhat interesting to me, because I think we are getting to that point where we're going to have to stop worrying about, getting to the next level of technology and more start worrying about like, how do we make this thing scalable, just not just balls to the wall against, the infinite sky. So
scalable and maybe just a little profitable, maybe making some of this
profitable would be good. Oh no, there's plenty of profit. I mean, Larry Ellison made tons of money, right? Like, now granted, it was the same money changing hands between the same companies, but hey, look at that they call that velocity of money. They call that in economics the velocity of money, right? And speaking of, actually, so I have we have an article from Finance, Yahoo Finance, talking about an analyst who sees a 38% downside for Oracle, mentioning that it's a quote unquote a risky blue sky scenario. What they mean by that, or what the analyst means by that, basically, is that essentially he's saying it's a bubble, right? Like the Oracle. The 5-year deal or whatever that was signed, for all of this money, is saying that the price of the stock is so far above the value of what is being delivered. In a 5-year window with AI is just absolutely phenomenally long, and basically saying the stock is not worth that, and this these deals that are these 5-year deals that are being penned probably won't actually go the distance, right? That's basically what the analyst is saying. So very, very interesting to see that finally, where somebody's calling out the bubble for what it is, kind of.
Yeah, that's exactly what I was going to say. It was just. Previously, you were just speaking of a bubble. This is kind of the manifestation of the bubble, right? I mean, obviously NVIDIA is in this camp too, kind of adding to this. But I mean, Jensen Huang is not a stupid person, but also he's he's not going to go against the grain on this one, right? If the path forward, by the market seems to be OpenAI and Oracle doing this deal, he's, there's money to be made from him no matter what, right? So it's not a bad triangle to be a part of for now, but yeah, it's just like, it seems like there was a fallout with the relationship with Microsoft, so now we switched over to Oracle, but like the facts are still the same at the end of the day. It doesn't matter which which big S corp is funding this, like, where OpenAI is not even profited or not even speculated to be profitable for another 5 years, something like that.
Yeah,
so
maybe.
Yeah, maybe that's projected, right? But I'm sure we can run this fucker into the ground well before then.
No doubt. But it's funny because they're burning this money, and how they're burning this money is promising it to like Oracle and then Oracle doesn't have the capacity that OpenAI is buying. They have to build it themselves, and to build it, they have to go to NVIDIA and give them $100 billion to buy the infrastructure to build the data center for OpenAI. It's just ridiculous, this velocity of money thing.
Maybe maybe this will happen again with Google or something after this relationship goes sour. We'll see.
It's truly ridiculous. I mean, if you think about it, like, there's so much money being created from, it's like Wolf of Wall Street style. Like, it's a Fugazi, it's fucking fairy dust,
All right. Next up, we have an article here from Cyberscoop. This is pretty big news, probably reported on by multiple outlets here, but this is the article that we pulled up today. But so Cisco has uncovered just a few weeks ago a new SNMP vulnerability that allows attacks on iOS XE based devices. So it looks like this flaw, which is, I don't know if it calls out exactly what the grade of the CVE is, but
it's high. There's several of them.
Yeah, right. But the flaw allows authenticated remote attacks with low privileges to force targeted systems to reload, causing denial of service. Higher privileged attackers could execute arbitrary code with root level permissions on affected Cisco iOS XE devices, effectively gaining complete control. So obviously, like, I hate kind of coming in here and just reporting on CVEs and things like that, because this happens to all of us, but Tim and I both work in vendor land where we're both going to be coming across CVEs on a pretty regular basis. That's just the nature of the game. Cisco has taken, the approach, kind of pushed out an immediate patch and is urging people to patch quickly and effectively. The problem is patching takes time, right? So, and not everyone does it on time. And, hopefully, I mean, to be honest, let's be completely honest here. We shouldn't be exposing SNMP to the internet anyway. So if that's the route that you've taken, then I would patch immediately, because you're already, to be honest, you're already doing bad practices. So at least patch, and then maybe move that to a more modern exchange of monitoring capability. But it's just wanted to call this one out because it's pretty important. So if you are potentially affected by this, definitely patch, and please stop exposing SNMP to the internet.
Yeah, this one, there's actually like 3 or 4 of these that were released at the same time, or just close to the same time. But yeah, and they're all around SNMP, and most of them are in the high scale. But all of them are like, why would you like find yourself in this situation where somebody could exploit this? If you've done any basic cybersecurity, you really shouldn't have found yourself in this hole. Not to make excuses, right? I mean, a CVE is a CVE and it needs to be fixed, but yeah. All right. Our next one has to do with Equinix. Equinix just did what they're calling an inaugural AI summit. And so they've released kind of a press release after that summit, talking about kind of the new feature functionality products that have come out of this summit that Equinix is offering. So let's go through it. They're calling it distributed AI infrastructure to help businesses accelerate. They mention Fabric Intelligence. So Equinix Fabric, of course, is the kind of their automation platform where you can create virtual machines and connect virtual machines to stuff that's in the Equinix rack, or to third parties, or to the internet, or to cloud providers or whatever. They're adding what they're calling Fabric Intelligence, which is AI insights based on telemetry tools that are available to be connected to the Equinix Fabric. So they can do things like, not only find the insights, you can chat with your network, essentially, type of thing, where you can say, hey, what was my, where am I having problems or something like that. But they can also, it says here specifically that, it can take corrective action around making the network responsive to demands and stuff. So pretty interesting if true, and if, let's see how it's implemented. It also mentions AI Solutions Lab at quote unquote Equinix Solution Validation Center facilities. So I think what that means is that there's like certain Equinix facilities where they'll have this connectivity to global AI partners. So this reminds me very much of the Megaport AI Exchange thing that Megaport just came up with the idea of just kind of inference or AI as a service, where they'll connect you to third party providers, like maybe with one of these many data centers that are being built to house AI workloads. So interesting. I don't know how much of that is out there yet still, that like these third party providers that will give you AI as a service, but they're building the capability out. And again, Megaport already has it with the already did something similar with the AI Exchange. So it makes perfect sense for Equinix to offer this. Yeah, that's kind of the long and short of that one. Anything to add there?
No, yeah, I think I was kind of with you. I was going to draw some correlations to the Megaport AI Exchange that they launched. I think it was, I don't know if that was earlier this year or even close to late last year.
I think it was this year. Yeah, earlier this year, I think.
Yeah. So this sounds like, kind of Equinix is also heading in that direction. It sounds like they've not necessarily one-upped it, but just obviously they have a few more capabilities that they've announced in this one summit as well. It sounds like the Fabric Intelligence piece is available Q1 2026, so that's coming up next year. And then the AI Solutions Lab, which we've kind of made adjacent callouts to the Megaport AI Exchange, is available now. It's like, the thing is, these things sound like big announcements, but at the end of the day, it's just kind of connectivity between
services.
Services and a service provider and a customer, which, that's kind of Equinix and Megaport together. That's kind of their bread and butter, right? Is building connectivity. The thing is, like, there's, even at this point, there's only a certain caliber of customer that is actually building their own AI type applications and things like that, right? So probably the kind of top end of town is who's going to use services like this, which obviously they're going to pay the most money as well. So that's good.
For sure.
But I just wonder how much this stuff is even getting consumed versus, some of it is vaporware at this point. It's announcements that things haven't actually been baked into the platform yet. But I wonder how much of this is actually getting consumed, because I would see adoption probably being rather low at this point. But that could hockey stick at any point. But that's where I see it now.
Well, and I think it's easy for Megaport and Equinix to just build that, kind of essentially build the road, right? It doesn't even really cost them much to do that, right? And then they can offer it as a service for interested customers. So for them, it makes probably perfect sense, right?
Probably makes much more sense for Equinix, because they probably own the goddamn data center anyway. So they're selling the data center space to the provider, and then just been like, yeah, we'll plug some cables in the meet room for you and bring you stuff. It's probably relatively easy for them. All right. Sorry, I was getting my windows situated. Okay. All right. Next up, we have an announcement from Alkira. So if you're familiar with Alkira, they are a multi-cloud networking vendor adjacent to the likes of Aviatrix or Proximo, etc. They have basically launched two products called Alkira MCP and Alkira NIA. Alkira MCP, you can kind of already determine what that is if you've been somewhat plugged into the world of AI at all. So they have a MCP server that's basically allowing you to interact with their AI agents and talk to your network, built on Alkira. And then they have this other tool as well called the NIA, which is the Network Infrastructure Assistant, which sounds like those things probably go together. I would imagine the MCP is how you would talk to the NIA ultimately. But, Alkira is kind of building that multi-cloud backbone. They have their own cloud exchange points or CXPs where they interconnect with each public cloud provider and kind of build that backbone for you to build between cloud regions or even cloud providers, and even into on-prem with the likes of their hybrid connectivity offerings. If it points out, I'll quote this directly, but there's a section in here from Alkira that say why this is different. And it says, point tools give snippets, not the story. Alkira pulls together everything on-prem, multi-cloud, between regions into one reliable picture and lets your in-platform co-pilot or trusted AI assistants use it to help gain faster path from observation to action to verification. Now, obviously if you're using your own in-platform AI tool like Copilot or any of your trusted AI agents, obviously this does give them a mechanism to talk to the network that you've built on top of Alkira, which makes perfect sense. And you probably can gain a lot of insight from that interconnectivity. But I would question how much of that can be between on-prem, because Tim and I worked for one of these vendors for a long time, so we have a lot of context around this. Is you own most of the cloud network, but you may not own any or much of the on-prem networks. And then there's even things like with the introduction of providers like Zscaler or any SSE or SASE type providers that also, they may integrate into this, but that doesn't necessarily mean that those type of things are going to be exposed via the MCP or via this network assistant that they're offering. So I would question really what extent you can go end to end. I'm not saying there's not value in seeing what Alkira owns end to end from their platform, but I do question whether or not it can really go as far as they're claiming. But we shall see. Any thoughts from you, Tim?
Nah, I think you nailed it. I mean, that's the question. The question is, how much can the NIA see to provide the insights that you're going to chat to it about? Mm-hmm. And then the MCP, I mean, it's an MCP server, right? So it's going to be exactly as useful as what you can write to do with it, right? I mean, in theory, it should basically, it'll work just like an API type of thing where, you can make changes or connect to or whatever you need to do with Alkira using their MCP server instead of their API or something like that. I just think of it like an AI API at the end of the day. So if you build an agent to make connectivity or use Alkira in some fashion, you've got an MCP to do it. You don't have to write the API stuff yourself.
Yep.
Okay. The last one is honestly feels a little science fiction-y, and then it's a little over my head, but we're gonna cover it anyway because it is really cool. So Cisco is expanding its quantum networking portfolio with new software prototypes. So what that means is, and this is where things really start to fall apart. So I've read this article a few times. So they have a package of prototype software that will facilitate quote unquote distributed quantum computing networks and support real-time applications. So the Quantum Labs designed a software stack that includes 3 layers, and I'm just reading this straight from the article because I don't want to say it wrong. An application layer with a network-aware distributed quantum computing compiler that supports quantum algorithm execution in a networked quantum data center. That means very little to me. It means a control layer with quantum networking protocols and algorithms that support the applications and manage the devices that make up the quantum network through APIs. And then a third layer for device support that's like an SDK and API to the physical devices. So basically, think of it, all I can get from this is that we're talking about a big quantum software development kit that like you can, goes from the application layer down to the hardware layer, and Cisco's making this available. What's really cool about this is, so Outshift, which is, essentially Cisco's kind of spun out think tank, if you will, for startups, announced a quantum entanglement chip. So they're able to actually do quantum entanglement with photons via this networking chip. And what this allows you to do, because quantum entanglement means essentially instantaneous state transfer between two entangled photons, is to distribute your computing in a way that it essentially becomes, there would be no latency in any kind of like network any operations between these networked computing quantum computers, which is crazy. You don't have to worry about we don't have to worry about fiber or anything. Apparently, like, can't get faster than entangled photons. So 200 million entangled pairs per second. The chip operates at room temperature, uses minimal power, and functions using existing telecom frequencies. The thing sounds like freaking magic. Like, I don't know what else to say. We're just talking about building data centers that are going to suck up the ocean and burn down the rainforest, and these guys are talking about quantum computers that operate at room temperature. Like, crazy stuff, right? So, I mean, again, read the article. I can't do it justice. The level of just craziness involved in this this new software stack is just really, really interesting, and what it might allow. It's funny to see technology not diverge, but just almost diverge, like just take two completely separate paths. So here we got AI doing what it's doing and just eating every resource on Earth to become smarter, faster, better. And then we have stuff like this that's kind of taking the other track, where quantum computing is actually so efficient that you're almost, you're not quite getting energy back, but like it's almost not using any. So I don't know. What do you think?
No, yeah, I mean, like you, Tim, I am but a simple man. So much of this article does go over my head. But the one thing that I do like they called out was the importance of the error correction, and to make sure that this is obviously accurate for transmission of photons and things like that. Because that's the thing that was, I think, the craziest thing is that it just sounded like all the existing infrastructure doesn't need to change. Maybe there's some chips involved here, but like you can use existing fiber, etc. Like you said, runs at room temperature. Whereas when we're hearing about these quantum computers today, it's like, oh, it needs to run at this temperature. It needs to be in this contained environment, because the errors that can be introduced by such a small variance in that type of stuff could be critical and potentially resource intensive and wasteful if it has to rerun some of these calculations. So like you said, the proof is going to be in the pudding. I think obviously there's a lot of detail in here, and Cisco's probably skating towards the puck in a lot of these type of scenarios. But I'm interested to see where this goes. The thing that's crazy about this is like this is all related to like computation, right? It's not necessarily related to the network. So it's kind of hard to grasp what this means for us as like network operators, right? It's like, it just sounds like shit's going to be moving really fast, like all the time. There's a lot of data moving really fast. So it's hard to kind of grasp what this means for where things are going to go, but things are changing. That's kind of the only constant is change, right? And I think that's definitely prevalent here.
Yeah, I forgot to mention one thing that I thought was also pretty cool. Another research this is a prototype. This doesn't exist as such yet, but the idea of quantum alert, which is like a security feature that can tell if two endpoints in a quantum link, if there's an intruder in the system, basically, because it's entanglement based. Apparently, they can rapidly detect if somebody shouldn't be there, essentially, if there's a thing in this that shouldn't be there. So they've already talked about this, and they're talking about like, basically by an intruder even entering, there's entanglement that has been screwed with and therefore is detectable. So I mean, think about cybersecurity, the future with quantum entanglement. I don't even know what to say about this, right? Like, anyway, so this is really cool. I highly recommend everybody read this article. Don't skip out on it. It's really, really interesting stuff. And with that, I think that does finish off our news episode. Thank you for sticking with us, assuming that you've made it this far, which if you're hearing this or say, you must have. So thank you.
You skipped to the end because you just wanted it to end that much faster.
Yeah. Yeah, there it is. Or you skip to the last story because this was this was probably the most interesting one. So anyway, all right, everybody. Well, thanks for sticking with us, and we will see you next month with another news update.